What's up, Vanessa? Times two. All right, so this next question is what is the domain of the f of f divided by g function? In other words, what is the domain of the quotient of f of x and g of x? First thing we need to do is we need to understand what this is, and it looks like you already know. You wrote down that this is x plus 5 over x minus 5. That's a really good start. So this is our function up above. So that's this function right here, f divided by g. Uh, the first thing is you need to understand what domain is. Domain are all the numbers you can plug into an equation and the equation gives an answer. Okay. Now, for most students, up until like Algebra 2 or even pre-calculus, that's the first time when you start to encounter problems where you can't plug the numbers in. All right. Sounds kind of weird, but let me give you an example. Last year, we talked about stuff that looked like this. So this is just a side example, stuff that looks like the square root of x. Now, the square root of x is one of those problems where you can't do everything. For example, you could plug in, like 0, 1. You can even plug in 2. The answer is ugly, but you could plug it in. Most people would like, let's plug in 0, 1, 4, 9, 25. Oops, forgot 16, right? They would plug those things in. But that's not to say that, a number like 3 or 8 or, 17, those numbers right there wouldn't work. Those would work, you just get really ugly answers. But in square root of x, if you got something like this, -1, that technically doesn't work in the real number system. We had to create a new number. If you remember, we created that iota, we created the I, right? The imaginary value. So if you have a negative inside of a square root, right? Negative, let's say even 4, that right there does not give you a real answer. And what we're trying to do is we're trying to define the numbers on the real system. So then you would be like, okay, well then what is the domain? Well, the domain is all of these numbers and none of these numbers. So in other words, the domain are all the positive values that you could plug in. You could plug in any, including decimals. Like, so if you wanted to plug in something like 0.25, you could totally plug 0.25 in here. The only restriction is you can't plug in negatives. So if I was to write the numbers in a number line, it would almost be like, all right, anything from here, starting at 0, and going this way, everything here, that would totally be acceptable. And over on the right side, left side, sorry, all of this would just be trash. Like, nope, none of that can work. All right. That's our domain for the square root of x. So we would say that the domain are all the numbers from 0 all the way through infinity. That's how we write it using set notation. So our domain for this problem right here would just be 0 to infinity, where 0 was where you start. Now let's do the same exact thing, but so let's look at it with this function. So you're like, well, what the hell? Well, when it comes to fractions, if the variable's in the denominator, this part right here cannot be 0. All right. Now, if you don't understand what I mean, well, like let's take a number like 5 and divide it by 0. You throw it in your calculator, and your calculator is like error, right? Your calculator is like, I don't know what to do. So numbers like 5 divided by 0, or anything divided by 0 for that matter, is undefined. So what we want to say is that this bottom cannot equal 0, the entire denominator. So then what we have to think is what are the numbers we can plug in for x that would make it 0? In other words, could we solve x minus 5 does not equal 0? Well, using your math from algebra 1 and just modifying it slightly, we would add 5 to both sides. This gives us x cannot be 5. Now, x can be anything else other than 5. X can be positive 6. It can be positive 4. You can plug anything you want in. You can even plug in 0 for x. It would not give you a denominator of 5. But the moment you plug 5 in, you would get 10 over 0, and then it malfunctions and it says error, right? Your calculator says that. It actually can't be calculated. It's impossible to divide by 0. So now how would you write this in set notation? So what you have is you have your number line, right? And then you have 0, and then you have 5. And this is where it's weird. 5 you cannot have. So we're just going to put a circle around it. Now, everything bigger than 5 totally works. And everything less than 5 totally works. So what you would write is that you want everything starting at 5 and going to infinity. But notice that I put a parentheses here, as opposed to over here where I put the bracket. So when you have a bracket, what you're saying is you can actually equal that number. And when you put a parentheses, you're saying you can't equal that number. But this only gives me the right side of the function. I still have the left side of the function, or the left side of the number line, to take into consideration. So on the left side of the number line, I have negative infinity all the way to 5. Now, it's these two sets that you want to use together. So we're going to include one more notation. We're going to include the union symbol. Be careful, the union symbol is not the letter U. You're actually going to have to pull up your calculator in your program. You're going to have to pull up the calculator that you have in WebAssign. I was trying to figure out the word for that. In WebAssign, you need to pull up the calculator and you need to punch in the key for the union symbol. You cannot use the letter U, otherwise it's going to mark it wrong. So if you put this into your problem, it would say that this is the correct answer. Or at least I hope it would. If it doesn't, we'll talk more tonight. Other than that, have a really good evening. Good luck tomorrow if I don't see you tonight, and I'll talk to you later.